Degenerative diseases and non-healing wounds are the result of a breakdown or interruption of the body's natural healing response, which is a complex and highly coordinated interplay among different types of viable cells, the soluble factors and extracellular matrix they produce, and vascular supply. Every organ and tissue in the body can be considered to have two fundamental compartments. The first compartment is the parenchyma, which consists of cells that are responsible for the defining activity or function of a given tissue or organ. Examples of parenchymal cells are myocardial cells in the heart, hepatocytes in the liver, and adipocytes in adipose tissue. The second compartment is the stroma, which consists of cells and structure that provide the structural and functional support for the parenchyma, including the intrinsic connective tissues, blood vessels, nerves, and ducts of the tissue. These healing and reparative cells are a heterogeneous population, including fibroblasts, parasites, immune cells, and stromal progenitor cells, and play an essential role in tissue maintenance, repair, and remodeling. For a chronic degenerative disease like osteoarthritis or a non-healing wound such as a diabetic foot ulcer, the endogenous stromal cells, those resident in the diseased tissue, are unable to achieve full regulation of the healing process, either due to insufficient numbers or impaired functionality. GID Technology addresses this reduced stromal cell function or activity by harvesting exogenous stromal cells from a small adipose tissue sample, isolating the healthy stromal cells from the sample, and then reimplanting the viable stromal cells to supplement the endogenous stromal cell population. The isolation of the stromal cells from adipose tissue sample takes approximately 60 minutes and is carried out at the point of care. The freshly isolated cells are reimplanted to the affected area where the cells engraft and respond in the dynamic and highly coordinated interplay among cells and soluble factors. After engraftment, these cells can replicate to provide new stromal and stromal progenitor cells for prolonged healing and progress toward homeostasis. The cellular interaction and replication is an entirely natural phenomenon, with the viable stromal and stromal progenitor cells responding and engaging in the healing process in a fundamentally biological manner. This cellular healing response is different than a cellular response to a drug. Drugs are synthetic chemical compounds, in other words, not containing live cells, that influence signaling or function by or between cells with no dynamic or reactive ability to participate in the complex and highly coordinated interplay among cells. In summary, low endogenous stromal and stromal progenitor cell numbers and/or impaired function are addressed by harvesting, isolating, and reimplanting healthy stromal cells that are derived from a small sample of adipose tissue from your own body.